Here we are on page 20 with numbers 13 through 20. It says combine into a single logarithm. All right, so we're going to use those rules of logs of powers being able to go up here, or coefficients out in front coming up to powers on there, and then the addition is going to make those multiplication and subtraction will make them division. Let's do it. Number 13 is going to be log base 4 x squared minus log base 4 of y cubed. And the subtraction means that these two things can be put into one logarithm, log base 4 x squared over y cubed. And there we go. Number 14. 1/3 5 log base 4 of x plus 7 log base 4 of y. If we jump this 1/3 in, we have 5/3. Number 14. Here we've got 5 out in front can go up on there, and 7 can go up on the y. So we have log base 4 of x to the 5th, and this is times y to the 4th. Are we okay with that one? And now we've got a 1/3 out in front. So the 1/3 can go up to the top as an exponent. So a 1/3 power is a cube root. So we can write it like this. The cube root of x to the 5th times y to the 4th. There we go. Number 15. Here we're going to take 7, put it up, 5, put it up, 2, put it up. So we have log base 4 of x to the 7th minus log base 4 of y to the 5th and plus log base 4 of z to the 2nd power. Subtraction means that this is really on the bottom, which makes sense. That we could have put that guy up as a -5 and he would have gone down on the bottom of a fraction. So we have one fraction, log base 4 of x to the 7th over y to the 5th, and z squared is up on the top because it is being added. There we go. Number 16. Ooh, we have a -2/7 that goes up on the x and a +4/3 that goes up on the y. So we have log base 5 of x to the -2/7 power times y to the 4/3 power. Again, addition of the two individual logs means multiplication when we put it into one single log. So this would then be log base 5 of y to the 4/3 over x to the 2/7. There we go. All right, number 17. Here we have a log base 3 on both places, and so we'll have log base 3 of this one, x plus 2, times, because there's a plus sign in here, x minus 2. Oh, hey, we know what x plus 2, x minus 2 is, right? So we could write it as log base 3 of x squared minus 4, multiplying those out like that. Good. Number 18. We have this 2 can go up on top there, and that 3 can go up on top there. And notice, yeah, as a minus sign, this will be on the bottom. Let's see if we can write that all at once. ln of x plus 5 with the 2 taken up to the top over, so subtract x minus 2 with the 3 carried up as an exponent on that one. Is that all right? Good. Number 19. Ooh, this is a really big one. This is going to be an x minus 2 squared. That's going to be an x plus 5 to the 2/5 power, and then a x minus 8 to the 7th power, but that guy will be divided. So let's see if we can write that out. Log base 7 of x minus 2 all squared times, because that was a plus sign, x plus 5 to the 2/5 power divided by x minus 8 all to the 7th power. And yeah, that's the same thing as moving a -7 up there and then multiplying it so it would come down to the bottom as well. All right, number 20. So this is going to be, we're going to have this go up on the x, that go up on the z, but it's going to be in the denominator, and that one's going to go up on the top. Okay, so we have 1/2. So we're going to end up square rooting something somewhere. But let's do this first. So we have 1/2 ln of x cubed over z to the 5th times y to the 7th. All right, so far so good. So that means this 1/2 out here can go up here on all of them. So it's ln of the square root of x cubed y to the 7th over z to the 5th. Now we should note right here that this could be written as a 3 halves power, 7 halves power, and z to the 5 halves power all inside here, which would have been the same as jumping the 1/2 in, distributing across these pluses and minuses, and we would have gotten the exact same answer. Okay, good.